1. Introduction, the file handle. In the last lesson, we learned that to achieve persistent data storage, we must interact with disk files via a stream, a sequence of bytes. To manage this stream, the C language uses a special type of pointer called a file pointer. About the file pointer, the file type is a struct defined in the stdio.h library. It holds all the necessary administrative information about the file: its current position, its mode, reading, writing, and status indicators. Because we interact with this structure via its memory address, we must declare it as a pointer, file*file ptr. This file pointer is your file handle, the way your program can access and manipulate the file on the disk. 2. Opening a file, the fopen function. The fopen function performs the critical task of locating the file on the disk, establishing the stream, and returning the file handle to your program. Here is the prototype of the fopen function. You can image the prototype like here. Parameters: file name, a string containing the name of the file, e.g., data.txt. Mode, a string specifying how you intend to use the file, read, write, append, etc. What file modes you can use: here are the common file modes. The mode R is to read. If the file exists, it will start reading from the beginning. If the file does not exist, the function returns null. Next, the mode W is to write. If the file exists, it will destroy existing content and start from the beginning. If the file does not exist, it will create a new file. And the mode A, this is to append. If the file exists, it will start writing at the end of the file. But if the file does not exist, it will create a new file. Next is code example, opening for writing. Three. Error checking, the null return. When fopen fails to open a file, for example, trying to read a file that doesn't exist, or lacking disk permissions, it returns the special pointer value null. You must always check if the file pointer is null immediately after calling fopen to ensure your program doesn't crash when trying to use an invalid handle. 4. Closing a file, the fclose function. Once you are finished reading or writing, you must close the file stream using the fclose function. You can image the prototype like here. So why closing is vital? First, data flush. Most C systems buffer write operations. They keep data in RAM temporarily. Fclose ensures that all remaining buffered data is safely written or flushed to the physical disk. If you don't close, you risk losing data. Second, resource release. It frees the system resources and makes the file available for use by other programs. Next is code example, closing the file. Five. Conclusion and next steps. You've learned the two essential steps for file management. About the open step, use fopen to establish a connection and get the file pointer. Always check for null. And about the close step, use fclose to ensure data is saved and resources are released. In the next lesson, we will finally use these functions to move data. We will explore 8.3, basic file reading and writing, using fprintf and fscamf for formatted I/O, which are the file equivalents of the printf and scanf functions you already know.